Hi everybody, this is Unit 2, Lesson 6. This is matrix equations. The objective is students will use inverse matrices and Cramer's rule to solve linear systems. So this is going to be bringing it all together. Here's the point in this lesson where we're going to learn how to use matrices to solve the problems from the beginning. So we're going to connect matrix and linear systems, and it's going to be a lot shorter, especially if you can use a calculator like a TI-83, which you will have for the test. If you don't, there's online calculators you can use. We'll get into that later. First, let's start out with this problem. Say I have that matrix equation. I have a 3 by 3 matrix times a column matrix that has x, y, z equals 4, 0, 11 in the answer matrix. So if I know how to multiply matrices, you have to remember you multiply the rows of the first matrix times the columns of the second matrix. Since there's only one column, we only have to do it once. So we move up the x, y, and the z, and we're going to multiply that and add times each row. So remember, you multiply what the numbers hit and you add your results. So in this case it's 0x, so just nothing, minus y plus 2z, and I know that has to equal the matrix 4, 0, 11. So I know that first row, first column has to be what I get. So I know that has to equal 4. So I get minus y plus 2z equals 4. I move the column down and I get 1x plus 1y minus 1z, so x plus y minus z, and that has to equal 0. Then I move it down to the last one and I get 2x plus 0y plus 3z has to equal 11. So you see what I have is I have a matrix equation, and when I multiply the matrix equation out, what I get is a system of equations. So for most of the problems we're going to be working on today, we're going to be going the other way. We're going to start with a system of equations, and we're going to turn that into a matrix equation, and then use what we know about matrices to solve the problem. So here's a smaller example of what I'm talking about. This is a 2 by 2 matrix. What I have is 2x plus 3y equals 11, and I have x plus 2y equals 6. The first thing I do is take the coefficients and turn them into a square matrix. So I have 2, 3, 1, 2, because those are the coefficients in the spot that they are on the linear system. I make that into a matrix. It's called the coefficient matrix. Then I have the variables in a matrix. I just make a column, x, y, and if I had z, it would be z on the bottom. That's the variable matrix. Then on the other side, I have the constant matrix. That's just the matrix of the answers to the two equations, if you would put it that way. The other side of the equal sign, which just is a constant number. That's why it's called the constant matrix. Now, in order to solve this, I'm going to first find the inverse of the coefficient matrix to do method 1. So if I find the inverse of the coefficient matrix, I do that by putting it into a calculator. I put it in the matrix menu if you're using a TI-84. Remember, it's second negative x to the negative first. That gives you the matrix menu, and you go over to edit and put it in. But the first thing I do is I find the inverse of the matrix. And when I do that using a calculator, I find that the inverse is 2, negative 3, negative 1, 2. And I'm going to multiply both sides of this matrix equation by 2, negative 3, negative 1, 2. I'm allowed to do this because of the rules of algebra. If I do it to both sides of the equation, then I haven't changed anything. When I multiply 2, negative 3, negative 1, 2, I use a matrix calculator to multiply that by 2, 3, 1, 2 on the left-hand side. I get 1, 0, 0, 1. And when I multiply the 2, negative 3, negative 1, 2 times 11, 6 on the right-hand side, I get 4, 1. Now on the left-hand side, that was by design. I know if I multiply a matrix times its inverse, I'm going to get the identity matrix, which is 1, 0, 0, 1. I want the identity matrix because if I multiply the identity matrix times x, y, that's the matrix equivalent of multiplying a whole number by 1. It doesn't change the number. So multiplying 1, 0, 0, 1 times x, y just results in x, y. So at this point, I have two equivalent matrices that are both 2 by 1s. I know x, y equals 4, 1, which means x has to equal 4 and y has to equal 1. So the answer to this problem is 4, 1, as was listed on this slide the entire time. I can use the same methods to solve a 3 by 3 matrix problem. You notice in this one I already set up the matrix equation. Normally this would look like 0x minus 1y plus 2z equals 4, x plus y minus z equals 0, and 2x plus 3z equals 11. This was actually the problem we did at the very beginning. This was the matrix equation that we had solved and shown that it was a system of equations. The first thing I need to do is find the inverse of the coefficient matrix. which I do by putting it into a calculator and then finding the inverse. In this case, it's 3, 3, negative 1, negative 5, negative 4, 2, negative 2, negative 2, 1. And I'm going to multiply that by both sides of the equation. Now, by design, I know the left-hand side of the equation is going to give me the identity matrix, so I'm not even going to put that in the calculator. I know it's going to be the identity matrix. What I need to do is do 3, 3, negative 1 times that matrix, the red matrix on the right-hand side, times 4, 0, 11. When I do that, I get 1, 2, 3. Again, the identity matrix doesn't need to be written. It's the equivalent of multiplying by 1. So that means x, y, z is 1, 2, 3, and that's the answer. Solving method 2 is Cramer's rule. This is going to use determinants rather than inverses to find the answers. So here's an example of a very similar matrix problem to the first one. All I did here was change the answer matrix. The coefficient matrix is the same as the one we did for inverses. Now, use Cramer's rule. The first thing you do is find the determinant of the coefficient matrix. In this case, I would use a calculator again to find the determinant. The determinant is 1. Next, in order to find the x value, I replace the x column of the coefficient matrix with the constant matrix, the answer on the other side. I then find the new determinant, which in this case is 4. I would found that using a calculator. And I divide that new determinant divided by the original determinant. So in this case, it's 4 divided by 1, so x is 4. To find y, I repeat the steps, only instead of replacing the x column by the answer matrix, I replace the y column by the answer matrix. I find the determinant of that with a calculator. I get 7. I take that answer divided by the original determinant, so it's 7 divided by 1, so y is 7. The answer to this problem is 4, 7. To show you a 3 by 3 example, I've used this matrix. Again, the initial step is to find the determinant of the coefficient matrix. I put that into a calculator, and I find the determinant is 34. Then I replace the x column to find the x coordinate. So I replace the x column, the y and the z columns remain the same, but the x column gets replaced by the constant matrix, and I find the determinant of that matrix. In this case, it's 68. I'm not finished though. I have to divide 68 divided by the original determinant. So 68 divided by 34, x in this case is 2. I repeat with the second column for y. I just replace the second column with the answer matrix, put the matrix into a determinant calculator, and I get negative 68 for this determinant, which when I divide by 34 tells me that y is negative 2. For the z column, I just replace the z column with the answer matrix. I find the determinant here using a calculator. I get 136. I divide 136 by the original determinant of 34, and I get that z equals 4. So the answer to these problems is 2, negative 2, 4. I've shown you 2 methods of solving these problems. So the homework for today, page 52, you have to solve problems 1 through 6. I want you to use the inverse method. And to solve problems 7 through 12, I want you to use Cramer's rules method. If you don't have a TI-84 at home, I know you have an internet connection because you're watching this video. I want you to find an online matrix calculator. You can find calculators that calculate determinants and inverses and that will multiply matrices together when you plug them in the calculator. We're all calculators here. Next time is study guide time, and good luck.